Recording, yeah.
Okay, can you hear me well on the microphone? Okay. Good morning, everybody. Thanks. At least I get you fresh first parallel session. I'm Frédéric Bosché. I was actually supervising Kai-Shi, who's the first author here at the University of Edinburgh, and she came visiting us from the Central South University in China for about a year. So that's the work, part of the work we did over that year. Unfortunately, she couldn't be here for the conference, so I offered to present for her. Okay, so in terms of background to this work, what we know is that construction remains a very unsafe sector, despite quite some improvement. I mean, you know, we keep on saying this, but the construction industry has made incredible improvements over the last decade or two. What is complicated is that, you know, how do you manage risk? How do you understand where risks are and to what is the degree of the risk is challenging because there's a lot of intertwined processes that happen during construction. So, and it's very dynamic. So it's very challenging to work out where the risks are, when they are, and therefore put maybe, you know, more extended safety features in place. In terms of previous research, this is a bit maybe narrow, but for the time of this presentation I'll do, but a lot of people work on risk management or risk, safety management. I've done some work related to the events or the workers, but typically one or the other, but not necessarily look at integrated frameworks of this. The work what we're doing, or the proposed approach, actually is fairly standard to some extent, but the main contribution is in the middle. We have a first step, which is about, we call it risk identification, but it's actually not just the risks themselves. The first part on the left is about identifying first what are the potential accidents, and therefore what are the risk factors that impact such accidents, that increase the likelihood of those accidents. Then we identify who are the workers involved in those activities, but also what is the timing of those activities, because timing is important. Not every activity lasts the entire duration of a project. And with this, we then propose to use a network-based modeling and analysis method. Essentially, we identify the risk chains. That is, a risk factor increase the likelihood maybe of another risk factor, and those chains go on until they may increase the likelihood of an accident. But these chains, they are not independent. They are kind of intertwined, and this is why you get these these network-like structures, like on the, I don't know if I can show my mouse. Yes, on this side here. But this is, at the beginning, this is just a static network. What we do is then we combine this with a timeline, and so we can get a network that represents the evolution of the risk chains and their interconnections over time, so as the project progresses and is delivered. And then once we have this dynamic network in place, we can just analyze it and identify, for example, for each trade, for example, what is the time when they are most at risk, or they are maybe most likely to generate risks for other workers, for example, or during, or when is the riskiest time during the delivery of the project. So the first part is the safety risk factor identification. We start from a set of accidents, and we identify the risk factors. Just the main thing I want to say here is these can be categorized in two groups. Those that are internal, that is within the project, created by the project itself, but there are also external risk factors that are related to the environment within which the project is delivered. And then we identify who are the construction workers that are related to the activities that generate those safety risk factors. And this can be found through construction methods, for example. We list who are the, when I say people, I mean the particular trades that are involved in the delivery. but it could be specific equipment or specific people. And finally, we have the timeline, and this is again because we start from the construction activities to identify all this information. We can, through the schedule, we can identify then when essentially a risk factor occurs, so the period during which a risk factor occurs. So we end up having these connections where we have the risk factors in the middle that are interconnected through the risk chains. We know we can find out which trade or which workers are involved in the generation of risk factors, and we know also the time when these risk factors are occurring. And all this is through the construction activity connection. So then we go through a process where we integrate all this into a unified network. So we first establish the integrated network between the workers and the risk factors. So for example, if, I don't know, a worker generates 2 risk factors, that creates 2 new nodes in our extended network. And then we integrate the time aspect of this. And so you can get, this is the network at time t1, and then time t2, for example, and then time t3. Okay, so you can see how the network grows over time and so on. And some nodes could disappear actually as well. So, and then obviously, which is something I don't discuss in this slide, actually I'll show later, is you can then do the analysis of this. Oh no, actually I have a slide here, okay. So you can, I show an example here. So if you have a risk factor caused by the construction, a given construction activity completed by a certain worker at a certain time, then we calculate a occupational safety risk index, which we calculate as the in-degree centrality of the network. So we use social network type analysis methodology to identify essentially the level of connectivity of each node in the network. And the in-degree centrality is a measure, is an interesting measure in terms of to calculate some occupational safety risk index. I should say the out degree also is, but we haven't actually discussed that at the time of writing this paper. This is something we're working on at the moment. So here we have, for example, a matrix that summarizes the connections between the nodes. And so we can look at for each node, the in-degree centrality is the number of connections that all the nodes point towards that node. And so by summing them, we get the in-degree centrality. And then we can analyze those results, for example, for a worker, a given worker. So in that particular example, would be the worker P3. Oh, it's actually not really. So these are the 2 nodes that contain worker P3 at the time T1. Then we can, for example, find out which one is the one with the highest occupational safety risk index. Okay, is it working? Yes. So that's the one here in the column. It's straightforward once you have the data to do the calculations. So Kaishi applied this to a case study in China. It's a tunnel. For this, they identified 3 major safety accidents and listed 49 safety risk factors. These are identified by analyzing documentation that is produced by the project management team, principally. But actually, when you look at them, they are pretty replicable. So they quite, they go from one tunnel project to another broadly. Obviously, there will always be some specificities of each different project, but actually, I think this information is quite replicable. There were 50 type of workers identified, 53, sorry, and this is an 18 months schedule. And so, I go through this, the same process, but with this example. So we had a static network here of the 53 risk factors. And so you can see how intertwined it is. The risk chains are just not independent of one another. And this is what the dynamic network kind of looks like. It's hard to represent, but you can see the important thing is to see how things get more complicated as time passes, because risk factors generated at the previous time can still impact some activities maybe down the road. So it tends to grow like this. And this enables us to calculate different, so it's a bit dancier, but it's all in the paper. The occupation safety risk indexes, sorry, for the different nodes in the diagram. And so, for example, then you can do an analysis that for each stage of delivery of the project. So, for example, here we have 18 periods, so we divided the project into 18 months, because it's an 18-month project. But you could have a more granular or less granular description of the timeline. And so at each time period, you can identify the construction activity, in particular the construction worker, which has the highest occupational safety risk index. And that can essentially attract the attention of the project management team towards this. And similarly, you can look at this some other way, for example, looking at the workers, but over the duration of the project, and see actually when their occupational safety risk is actually at the highest or at the lowest, but you can see how it evolves. Okay, so quick conclusions. So we defined some sort of approach, let's say, to establish the relationships between workers and the safety risk factors, and the timing and the safety risk factors, and then also the relationship among safety risk factors. At the heart of this is actually the connection of all of these to the construction activities that take place. And by the way, when I say construction activities, I mean this very broadly, because some activities can include design type of activities. Okay, so design and planning activities can, you can make errors that can have some knock-on effects down in the delivery. And then we conducted a dynamic evaluation, essentially based on social network type analysis. We call it a dynamic occupational safety risk network. And so far we've applied metrics like in degree centrality, but actually it's actually not enough. So in degree centrality only captures one aspect of the importance of a node, but out degree centrality also is an important aspect in terms of risk assessment. And essentially one is about the likelihood, so the in degree centrality kind of represent the likelihood that a risk factor will occur, while the out degree centrality will give you an estimate of the level of impact that risk factor will have on the rest of the project. And so the combination of them, likelihood versus impact, actually produces probably a better metric of risk, because this is how we tend to measure risk. Okay, that's me. Thank you very much. Happy to take any questions.